Welcome to this session, where we unlock the true brain of programming, conditional statements and flow control in PHP. In this video, you won't just learn code, then you'll understand the logic that powers every intelligent system around you. From choosing what action to perform, to responding to real-time conditions, to making programs behave just like human decision-making. This is where programming becomes alive. So get ready, because we're about to turn simple code into powerful logic and build the foundation for dynamic, responsive, and smart applications. Let's begin.
In programming, conditional and flow control statements play a crucial role in guiding the computer through different paths of execution based on the conditions we provide. They allow programs to make decisions, repeat actions, or choose between multiple options. The most basic form of decision-making is the if statement, which checks whether a condition is true, and if it is, it executes a specific block of code. An if-else statement extends this idea by providing an alternative block of code that runs when the condition is false. For more complex situations, programmers use if, elseif, else statements, which allow multiple conditions to be checked one after another until one of them matches. Another important conditional structure is the switch statement, which is especially useful when choosing between many possible values of a single variable, making the code cleaner, easier to read, and more efficient than excessive nested if statements. After conditional statements, the next essential concept is looping, which enables a program to repeat actions without writing the same code multiple times. The while loop continues running as long as its condition remains true, making it useful when the number of repetitions is not known beforehand. The do-while loop is similar, but it guarantees that the loop body runs at least once because the condition is checked after the code executes. The for loop, on the other hand, is ideal when you know the exact number of iterations in advance, such as counting from one number to another. Many programming languages also include the for each loop, which simplifies the process of going through each element in a collection, like items in an array, without manually managing indexes. Within loops, programmers sometimes need to change the normal flow, and for that, they use break and continue statements. The break statement immediately stops the loop entirely, while continue skips only the current iteration and moves to the next one. Another important concept in this session is arrays, which allow a single variable to store multiple values of the same type. Instead of creating many separate variables, an array organizes related data into indexed positions, making it easier to manage, search, and manipulate. Arrays come in different types, including one-dimensional arrays, which work like simple lists, and multi-dimensional arrays, which can represent structures like tables or grids. Finally, the session also covers sorting functions, which arrange the elements of an array into a specific order, such as ascending or descending. Sorting algorithms range from simple techniques like bubble sort to more efficient methods such as quicksort or merge sort. Understanding different sorting methods helps programmers choose the right approach according to the size of the data and the performance requirements of the application. Building on the earlier discussion, it is important to understand that conditional and looping constructs truly form the core of how PHP programs make decisions and perform repeated actions. In this session, the focus deepens by looking more closely at the practical use of these constructs in PHP. The lesson begins by revisiting conditional statements such as if, else, elseif, and switch, explaining not only what they are, but also how they behave when PHP evaluates different conditions. Each construct is described in terms of when it should be used. For example, simple choices can be handled with if statements, while more structured, multi-option scenarios are more efficiently handled using a switch statement. The session highlights the importance of choosing the correct conditional structure so your code remains readable, efficient, and well-organized. Next, the session moves into loop constructs and describes how PHP uses while, do while, for, and for each loops to repeat blocks of code. The explanations emphasize the logical differences between these loops. A while loop continues to run as long as the condition stays true, while a do-while loop ensures the body executes at least once before checking the condition again. The for loop is shown as the ideal choice when the number of iterations is known beforehand. Meanwhile, the for each loop offers a simplified way to work through arrays without manually tracking indexes. The session also introduces two special control statements, break and continue, which allow programmers to interrupt or skip parts of a loop. Break stops the loop entirely, while continue jumps directly to the next iteration, skipping any remaining statements within the loop body. These features are essential for managing how and when loops execute under different conditions. Finally, the session transitions into the concept of arrays in PHP, explaining that arrays allow you to store multiple pieces of related data under a single variable. It introduces single-dimensional arrays which store values in a simple list and associative arrays which store data as key value pairs, making them ideal for representing labeled information such as names, ages, or locations. The explanation covers how arrays can grow, shrink, and be manipulated to store different kinds of data. After describing the types of arrays, the session concludes by exploring PHP's built-in sorting functions, which allow arrays to be arranged in alphabetical, numerical, ascending, or descending order. Functions like sort, rsort, asort, and ksort are introduced to show how PHP provides powerful and flexible tools to organize data efficiently. By the end of this section, learners gain a clear and practical understanding of how conditional logic, loops, and arrays work together to form the backbone of dynamic PHP programming. As the session progresses, it begins to focus specifically on PHP conditional statements, which are essential tools for decision-making in a program. Conditional statements allow PHP to choose different actions depending on whether a given condition is true or false. When a programmer writes PHP code, there are countless situations where different outcomes are needed. For example, validating user input, checking login credentials, responding to user choices, or performing different operations based on the values of variables. In all these cases, PHP relies on conditional statements to evaluate conditions and guide the program along the correct path. These conditions are always evaluated into Boolean values, meaning they resolve to either true or false. Based on the result, PHP decides which block of code should be executed. The process can be thought of as a decision tree. The program starts, checks a condition, and depending on the result, follows one of several possible paths. The diagram shown in the image visually represents this decision-based logic. When PHP encounters a condition, it asks, "Is this condition true?" If the answer is yes, it performs a specific action, such as printing a message or executing a function. If the answer is no, it either checks another condition or moves to a different block of code that defines what should happen when the original condition is false. This step-by-step evaluation makes PHP conditional statements powerful and flexible. They allow developers to write logic that adjusts to different inputs and scenarios, making programs intelligent and responsive. By understanding how PHP evaluates conditions and how these statements work together, learners can build dynamic code that reacts smoothly to real-world situations. As we move further into the concept of decision-making in PHP, it becomes essential to understand the different types of conditional statements supported by the language. Each conditional structure allows a program to respond differently depending on the situation, making the code flexible and intelligent. PHP offers four main types of conditional statements: if else, if, else if, else, and switch. Although all of them serve the purpose of guiding program flow, each one is suitable for specific kinds of decisions. The simplest of these is the if statement, which executes a block of code only when a particular condition evaluates to true. If the condition is not met, the code inside the if statement is simply skipped. This type of conditional is used when you want to perform an action selectively. For example, checking if a user is logged in before allowing access to a page. It is the most basic form of decision-making and serves as the foundation for more complex conditional structures. Next is the if-else statement, which adds an alternative path for when the condition is false. In this structure, the program checks the condition. If it is true, it executes the code inside the if block, but if it is false, the else block executes instead. This is useful when exactly one of two outcomes must occur, such as approving or denying access, accepting or rejecting an input, or displaying success or error messages. When decisions involve multiple conditions, PHP provides the if, elseif, else statement, which allows the program to evaluate several different conditions in sequence. With this approach, PHP checks the first condition. If it is true, the corresponding code runs, and the rest of the conditions are ignored. If the first condition is false, PHP moves to the next condition and evaluates it. This continues until one of the conditions is true. If none of the conditions match, the final else block executes. This structure is ideal for selecting between 3 or more logical branches, such as categorizing exam marks, identifying user roles, or choosing different modes in an application. Finally, PHP includes the switch statement, which is designed to handle scenarios where you need to choose one action out of many possible options based on the value of a single variable or expression. Instead of checking multiple conditions individually, a switch statement compares the value against a list of predefined cases and executes the code that corresponds to the matching case. This makes switch statements especially useful when dealing with menu selections, user commands, or predefined categories. With switch, the code becomes cleaner and more readable compared to writing multiple else-if statements. Together, these conditional structures form a powerful set of tools that determine how a PHP program behaves in different situations. Understanding when and how to use each one is a key step in writing logical, efficient, and organized PHP code.
To understand the if statement more clearly, it helps to relate it to simple, everyday decision-making. Think about a real-life situation. You plan to go outside during monsoon season. Before leaving your home, the first thing you do is look at the weather. If the sky appears dark and cloudy, you immediately decide to carry an umbrella or a raincoat with you. On the other hand, if the weather looks bright, sunny, and pleasant, you know you do not need to carry any rain gear. This natural way of making decisions is based entirely on evaluating a condition, in this case, whether it is likely to rain or not. This thought process directly mirrors how an if statement works in PHP. The program first checks whether a condition is true. If the condition turns out to be true, PHP runs a specific block of code. If the condition is false, PHP simply skips that block and continues with the rest of the program. In the analogy, the condition is whether it is raining. If the condition is true, the action is to carry an umbrella. If the condition is false, you ignore that action and go out freely. This kind of decision-making is fundamental in programming because applications often need to react differently based on the situation. For example, an online form may check whether all fields are filled before submission. A website may check whether a user is logged in before showing private content. Or a banking system may check whether the balance is sufficient before processing a withdrawal. Each of these actions depends on conditions, and the if statement allows PHP to evaluate those conditions and execute appropriate actions. The diagram in your image visually represents this logic. If the condition is raining evaluates to true, then the program executes the block associated with the if statement. If the condition is not true, the program naturally follows an alternate path, eventually leading to a different action. This demonstrates the simple yet powerful nature of the if statement. It enables a program to decide what to do based on real-time inputs, data, or situations. By mastering the if statement, learners take their first step towards writing responsive, logical, and intelligent PHP programs. To understand the if statement more clearly, it helps to look at what happens inside a program the moment an if condition is encountered.
In PHP, an if statement begins with the keyword if, followed by a logical condition placed inside parentheses. This condition is something PHP must evaluate to decide which path the program should follow next. The condition can be a comparison, such as checking if a number is greater than another number, or checking if a variable contains a specific value. Regardless of what the condition is, PHP always evaluates it into a Boolean result, either true or false. Once PHP receives the result of the condition, it follows a very clear flow of execution. If the condition evaluates to true, the program enters the block of code written inside the braces following the if statement. Everything inside that block is executed line by line. After completing the block, the program moves on to the next part of the script. This is similar to a real-life decision, where after confirming that a condition is met, you carry out the required action. However, if the condition evaluates to false, the program does not execute the code inside the if block at all. Instead, PHP skips the entire block and directly moves to the next instruction that appears after the closing brace of the if statement. This ensures that only the correct action is performed based on the condition provided. In other words, the program only executes the code that is logically appropriate for the current situation. The diagram in your image illustrates this flow beautifully. At the top, you see a condition block, which represents PHP evaluating the expression placed inside the parentheses of the if statement. If the condition is true, execution flows downward into the code block shown as a green box. If the condition is false, the program follows a different path, bypassing the code block and directly moving to the next step. This clearly shows that the if statement is not about forcing the program to do something. Rather, it is a controlled mechanism that allows the program to decide whether a specific action should be taken. By understanding this internal flow, learners can appreciate how important and powerful the if statement is in programming. It forms the foundation for decision-making and plays a major role in creating programs that behave differently under different circumstances. Every time a program needs to respond to input, check a value, validate something, or choose between actions, the if statement becomes the essential building block that makes this logic possible. To further strengthen your understanding of the if statement, the flowchart in the image provides a simple and clear visual example of how PHP handles a conditional check during program execution. In this example, the variable num is assigned the value -4, a negative number. The program then encounters an if statement asking a very straightforward question: is num less than 0? This question becomes the logical condition that PHP must evaluate. When the program reaches the condition, it pauses and examines the value stored inside the variable num. Since -4 is indeed less than 0, the condition evaluates to true. Because the condition is true, PHP enters the block of code associated with the if statement. In this case, the action taken by the program is to print the message, "The number is negative." This message is only displayed because the condition was satisfied. Once this block of code is executed, the program continues to the next instruction or reaches the end of the script, depending on what comes after the if block. However, the flowchart also shows what would happen if the condition evaluated to false. Imagine instead that the value of num was something like 5, or 0, or any number that is not less than 0. In that situation, the expression num less than 0 would not hold true. Since the condition is false, PHP would skip the entire code block that prints the message. The program would bypass that action completely and move directly to the next step, which, as shown in the flowchart, is simply the end of the script. This example highlights the most important principle behind an if statement. The code inside the if block only runs when the condition is true. If the condition is false, nothing inside the block is executed. The flowchart makes this crystal clear by showing two separate paths, one for true and one for false, ensuring you understand exactly how the decision-making process unfolds inside a program. This structured flow of logic is what allows PHP programs to make intelligent decisions based on the values they receive. After understanding the conceptual behavior of the if statement, it is equally important to see how it is written in PHP. The syntax of the if statement is simple, yet extremely powerful. It begins with the keyword if, followed by the condition placed inside parentheses. Immediately after the parentheses, a pair of curly braces is used to wrap the block of code that will run only when the condition evaluates to true. This structure makes it easy to visually separate decision-making logic from the rest of the program. Inside the curly braces is where you write the action or instructions that should be executed when the condition holds true. If the condition is false, PHP automatically skips everything inside this block and continues with the next statement outside the braces. This separation ensures clarity in program flow and prevents unintended execution of code. The syntax is clean, readable, and consistent with how logic is represented in flowcharts. A condition is checked, and only if the condition is true does the flow proceed into the designated branch of the program. The code snippet shown in the image demonstrates this logic in action. The variable $num is assigned the value -764, which is clearly a negative number. The if statement checks the condition. If $num is less than 0. Here, PHP evaluates whether the value stored in $num is less than 0. Because -764 is indeed less than 0, the condition evaluates to true. As a result, the program enters the if block and executes the line, "Echo the number is negative." This leads to the output, "The number is negative." The example perfectly mirrors the decision-making sequence represented earlier in the flowchart. The program starts by reading the value of the variable, checks the condition, and depending on the evaluation, either executes the block or skips it. In this case, because the number meets the condition of being negative, the program prints the corresponding message. If the value had been positive or 0, nothing inside the if block would have been executed, and the program would have simply moved on. This example reinforces how essential conditional statements are in programming. Even a single if statement can be used to validate user input, determine program behavior, or selectively execute instructions based on dynamic data. By practicing with such simple conditions, learners build a strong foundation for writing more complex decision-making logic later. Building on the earlier examples of the if statement, Code Snippet 2 introduces a slightly more practical and real-world scenario where conditional logic is used to check the current time. This example helps illustrate how PHP can make decisions dynamically based on the environment or system data. In this case, the goal of the program is straightforward. It should display the message, "Happy morning," if the current system time is before 12 o'clock noon. The program begins by using PHP's built-in date function. The function call date retrieves the current hour of the day in a 24-hour format, where the value ranges from 00 to 23. This value is then stored in the variable time of day. For example, if the current time is 9 a.m., the value in time of day will be 09. If it is 3 p.m., the value will be 15. This demonstrates how PHP can interact with the system clock and use time-based information for decision-making. Once the hour value is stored, the if statement performs a simple comparison. If time of day is less than 12, echo happy morning. Here, PHP checks whether the current hour is less than 12. If the condition is true, meaning that the current time falls in the morning hours, the program executes the code inside the braces and prints happy morning to the screen. If the time is 12 or later, the condition becomes false, and the program does not display anything. This neatly demonstrates how conditions allow programs to tailor their output depending on real-time data. The output shown in the image indicates that at the moment this program was run, the hour value retrieved was indeed less than 12. As a result, the condition evaluated to true, and the message, "Happy Morning," appeared. This type of logic can be extended further to create greeting systems, time-based notifications, or even dynamic websites that change messages depending on morning, afternoon, or evening. What makes this example especially valuable is that it shows how if statements can go beyond simple numeric comparisons or user-provided values. They can work with system information, environmental data, or even external inputs, making PHP capable of creating intelligent and context-aware applications. With this snippet, learners can clearly see how an if statement links a real-world scenario, time of day, to a functional program output.
Up to this point, we have seen how a simple if statement allows a program to execute a block of code only when a condition evaluates to true. However, in real-world programming, decisions are rarely that one-sided. Very often, you need the program to perform one action when a condition is true, and an entirely different action when the condition is false. This is where the if-else statement becomes essential. The if-else construct expands the decision-making capability of the program by providing two clearly defined paths of execution. It begins with the traditional if block, where the given condition is evaluated. If the condition is true, the program enters and executes the statements inside the if block. But unlike the simple if structure, the program now has an alternative action defined in an else block. The else block is executed automatically whenever the condition in the if statement evaluates to false. This ensures that exactly one of the two actions will always be taken, either the if block or the else block, making the program's behavior predictable and logically complete. Consider a situation where you want to check whether a user enters the correct password. If the password is correct, the if block may allow login. If the password is wrong, the else block may show an error message. In such cases, it is not enough to simply do something when the condition is true. You also need to define what should happen when the condition fails. The flowchart in your image illustrates this decision structure very clearly. It begins with a condition represented at the top. If the condition is true, execution flows to the right and the if block is executed. If the condition is false, the flow moves downward and the else block is executed instead. This simple branching makes the program capable of handling two opposite outcomes with clarity and precision. The else block always starts with the keyword else, followed by its own set of curly braces containing the code that should run when the condition fails. This maintains a clean and organized structure. Another important point is that the else block does not contain its own condition. It exists solely as the default action, the fallback path that the program takes when the original condition is not met. In summary, the if-else statement gives your program the ability to respond intelligently to both outcomes of a logical test, not just the success case, but also the failure case. This is an essential tool in programming, enabling the creation of applications that can handle real-world situations where decisions always have two possible sides. The flowchart in the new image provides a simple yet very effective demonstration of how the if-else statement works in practice. In this example, the variable num is assigned the value 10. The program then evaluates the condition, is num less than 0? This condition becomes the decision point for the entire flow. PHP checks the value of num, which is 10, and compares it with 0. Since 10 is not less than 0, the condition evaluates to false. This false outcome determines which path the program will follow next. If the condition had evaluated to true, meaning if the number were actually negative, the program would have executed the block of statements associated with the if part of the code. In that case, it would have printed, the number is positive. This indicates that the if block is responsible for printing the message associated with the true outcome of the condition.
However, because the assigned value is 10, the condition num less than 0 is false. Therefore, the program moves into the else block, which holds the action meant specifically for the false condition. As a result, the program prints the number is negative. This behavior demonstrates the key strength of the if-else construct. No matter what the condition evaluates to, the program always chooses exactly one path. It either executes the code inside the if block if the condition is true, or executes the code inside the else block if the condition is false. There is no situation where both blocks execute, and there is no situation where neither block executes. The flowchart beautifully visualizes this branching logic. Starting with the assigned variable, the flow moves to the condition. If true, the arrow leads to the green box. Print, the number is positive. If false, the arrow leads to the red box. Print, the number is negative. Once the appropriate message is printed, the program ends. This example reinforces why the if-else statement is so useful in programming. It allows you to handle two opposite outcomes of a single condition in a clear and organized way. You decide what happens when a condition succeeds, and you also define what happens when it fails. This balanced structure helps programs behave reliably under all circumstances.